Hello everyone, welcome to AS Engineering Academy and AS Online. This is Ramesh Pabba, faculty at AS Engineering Academy. In this, we are going to have the ISRO PYQs, ISRO examination PYQs from the subject called measurements. So in this measurements PYQs from the ISRO paper we are going to take. The first question is, AC current cannot be measured by. AC current cannot be measured by. Kindly observe the question properly. He is not asking can be measured by. He is asking cannot be measured by. So simply hardware ammeter, yes, AC possible. Moving an ammeter, AC is possible. Thermocouple type ammeter also AC is possible. So straight away where it is not possible means moving coil ammeter, we cannot get the AC directly because moving coil ammeter means PMMC instrument. Obviously with PMMC AC current cannot be measured directly. So answer is moving coil ammeter. Second one, the internal resistance of a voltmeter should be. He has given that very high, right? Internal resistance of the voltmeter is very high. In order to have, he is saying that voltmeter resistance is high. Okay, that is correct. But why that is made up of high resistance means simply if the voltmeter is connected, of course, across the entire load or something we can say, right? Now, the moment whatever the current is coming from the supply, voltmeter should draw less current, load should draw required major current we can say. So that's why correspondingly what we can say, voltmeter should draw less current, therefore the load will be properly satisfied. So that is the reason why voltmeter must be designed with very high resistance. That's why to minimum current through the meter. What is that? The voltmeter is designed with high internal resistance to have minimum current to the meter. Therefore the load will not be disturbed. Right? Next one. The resistance of the thermistor. Guys, the thermistor is having negative temperature coefficient of resistance. The thermistor is having negative temperature coefficient of resistance. Now, the negative temperature coefficient means what is the meaning? If the temperature is increased, automatically resistance will be decreased. No, the resistance of a thermistor is dash. Resistance of thermistor decreases with increase in temperature. Here increases with increase in temperature, wrong. Remains constant, wrong. Remains constant, wrong. So what is the answer? Decreases with increase in temperature because inversely proportional. Right? Next one. A meter has a full scale deflection of 90 degrees. Current of 1 ampere. So therefore, what is the value? 90 degrees for 1 ampere of current. And the response of the meter is square law. So response means theta proportional to I square, we can write directly. Of course, assuming spring control they have given. And the current for a deflection of 45 degrees. So for 45 degrees, so what is the value? Now for this small basic idea I am giving, generally response means simply TD proportional to I square is given. And the 2 spring control is given means TC is equal to KC theta, therefore TC is proportional to theta we can write. And at final position what we can write? TC is equal to TD, therefore we can write theta is proportional to I square. So this is what the concept behind this. And he has given that response of the meter is square law, we can write that. Now from this what we can write? Theta 2 by theta 1 is equal to I2 square by I1 square. I2 square by I1 square. What is theta 2? 45. Theta 1, 90 is equal to I2 we don't know. I2 square and I1 1 square. So therefore what will be their value? I2 square is equal to 1 by 2. I2 square equal to 1 by 2. Therefore I2 is equal to 1 by root. This value will be 0.707 amperes. Simply numerical question. Answer is 0.707. Check it. Yes, this is the answer. Right? Next question. A single phase energy meter operating on 230 volt 50 Hz supply and load current of 20 ampere, time of operation is 2 hours, power factor is unity, UPF he has given. The meter makes 1380 revolutions in that period. The meter constant is dash. Very, very simple. In this energy meter, whenever you are getting the question from the energy meter, that is very, very simple, because if you stand with respect to the units, answer will be there. What is it, sir? Meter constant unit is revolutions per kWh. So what is that? Revolutions we require. Yes, he has given 1380 revolutions. So what we need to determine? kWh, nothing but energy. So therefore, what is the energy formula? Energy formula is V into I into cos phi into time. Okay. What is V? What is V? 230 volt. What is current? Current is 20 amperes into power factor is 1. Power factor is 1. And time of operation. See, 230 into 20 into 1 means V into I into cos phi. This is watts. I am making that into kilowatts by dividing with 1000. Into time of operation is 2 hours. Sir, this is kilowatt and this is hour. Therefore, the value we are getting in kilowatt hour notation. Now, if you are simplifying this, what will be there? 2 2s are 4, and correspondingly, if you are taking that, we are going to get 9.22 kilowatt hour. This is the energy, 9.2 kilowatt hour. But what he is asking? Meter constant. So what is meter constant formula? Meter constant is equal to number of revolutions 1380. Number of revolutions 1380 by how much value? 9.2 kilowatt hour. 9.2 kilowatt hour. If you simplify this, we are going to get 150. We are going to get 150 revolutions per kWh. 150 revolutions per kWh. This is the meter constant. What I told you, very simple. Whatever you require, stand with respect to the unit. Revolutions there, kWh, yes. Voltage, current, power factor, time. So simply kWh. So answer will be 150. Yes, option B. Right? Next question. In case of power measurement by 2 wattmeter method, right? Here, balance the three-phase system with pure inductive load. Pure inductive load means, what is the power factor? Power factor is 0. 0, the 2 lagging. Power factor is 0 lagging. Why, sir? Inductive, lagging, pure means simply 0. 90 degrees will be there. Cos phi is 0. Sir, power factor is 0. This is possible when in the corresponding power measurement topic we are having 5 points. Among those, if both wattmeter readings are equal and opposite, the both wattmeter readings are equal and opposite, then the power factor will be 0. So therefore, automatically both wattmeters will indicate the same value but opposite sign. Yes, this is correct. That's why in the topic also we have seen, right, whatever the corresponding 5 points are there, definitely one question possible. I told you in the other different competitive examinations. So this is the question from that model only. I gave you 5 points. This is the 5th point. W1 is equal to minus W2. The power factor will be 0. Right? Next. Both wattmeter will indicate 0. No meaning. Both wattmeters will indicate the same value, same sign. Same value, same sign means for this power factor will be 1. But what he has given, what is it? Pure inductive load means power factor is 0, means this one. But this is power factor 1. And one wattmeter will indicate 0 and the other will indicate, right, some non-zero. So for this, what is the power factor? The power factor for this is 0.5. So what is our requirement? Power factor is 0. So automatically equal but opposite. Right? Next question. To measure current, ammeters are connected in. Very simple question. Right? In order to measure the current, ammeter must be connected in series. So therefore, let us cancel parallel and parallel. Okay. Series is there, okay. But ammeter should be designed with which resistance? Low resistance. So ammeter always designed with low internal resistance, very low internal resistance. And this ammeter must be connected in series in the circuit. Series in the circuit. Why series in the circuit? Obviously, generally basic point. It is for measurement of current. So therefore, yes, it is connected in series, and the two internal resistance must be designed with low. But here series okay, with high resistance wrong. So therefore, answer is ammeter must be with low resistance and it must be connected in which one? Series. So therefore, simple points I am giving. Ammeter, right? Low internal resistance. Earlier question voltmeter was there, no? I am giving that point again. Voltmeter, internal resistance very high. Ammeter must be in series in the circuit. Voltmeter must be parallel in the circuit. Very simple. Right? Next question. It is also numerical question. 2 wattmeter method. 2 wattmeter method is used to measure the input of a balanced 3-phase circuit. Indicates 2000 watts and 500 watts respectively. One wattmeter 2000 watts, other wattmeter 500 watts. What will be the power factor of the circuit when both of the readings are positive? Means this is a positive 2000, this is positive 500 only. Now the point here is, what is the power factor formula? Right, in the class also we have taken, what is it? This formula, power factor formula, very popular. From this formula, 5 points are generally possible. Earlier question is from that only. What is the power factor formula? Power factor cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. This is the power factor formula. Okay, right. Now, sir, what is the corresponding wattmeter reading they have given? Cos of tan inverse root 3. One wattmeter is 2000, other wattmeter is 500. So therefore, let us substitute 2000 minus 500 by 2000 plus 500. You need to simplify this. If you simplify this, you are going to get 0.69 something. If you are simplifying this, you will be getting 0.69. Check the options, which is the correct option. 0.8, 0.565, 0.75. So simply 0.69 is the answer. Right? In this way, you need to remember the formula. You have to simplify. Answer is 0.69. Right? Next question. Wheatstone bridge is used for measurement of. Wheatstone bridge, obviously medium resistance we can say. Wheatstone bridge is used for measurement of medium resistance. But let us have some other options. Very high resistance or generally high resistance we can say. Normally high resistance. High resistance is by which one? Direct deflection method, loss of charge method, meg-ohm bridge method and Megger. And low resistance, generally low resistance we say, for low resistance potentiometer method as well as Kelvin double bridge method. Like that, you need to remember all the names. By the names itself, yes, Wheatstone bridge is for medium resistance measurement. Direct question. Next one. A power factor meter connected in a circuit indicates power factor of 0.6 lagging. Okay, power factor meter is connected to measure the power factor. They observed as 0.6 lagging. 0.6 power factor is little bit poor power factor only. Generally what we expect? 0.8 or 0.8 plus etc. So 0.6 means low power factor we can say normally. To improve the power factor, we have to insert the following component in the circuit. Very simple, basic electrical point. Whenever we are supposed to increase the power factor, which element must be added? Capacitance must be added. Yes, by adding the capacitance, what will be there? Capacitor means leading element. Therefore, whatever the lagging is there, that will be reduced. So therefore, power factor will be improved by adding the capacitor. Right? Next one. The sensitivity of an instrument. These kind of questions, you need to follow all the options clearly, because Question is very simple, answer is very simple, but selection of option must be very much careful. What is it, sir? Sensitivity formula. What is sensitivity formula? Delta output by delta input. This is one formula. What is that? Ratio of change in the output by change in the input. In that way, recollect the formula and check the corresponding options. What is that? Here, the smallest increment, no. The largest input, no. So simply here, ratio of the change in magnitude of the output, change in magnitude of the output to the corresponding change in magnitude of the input. So therefore, what is the meaning of this? Yes, delta output by delta input. Therefore, answer is this. Right? Next question. Low resistance is measured with Kelvin double bridge method. Direct answer. Low resistance is measured with Kelvin double bridge, and also potentiometer method is also there, but among the available options, Kelvin double bridge is the answer. But let us complete other options also for better clarity. De Sauty's bridge is for which measurement? Capacitance measurement. Maxwell's bridge, which measurement? Inductance, we can say. Self-inductance, we can say. Self-inductance. Wien's bridge is for which one? Frequency measurement. So therefore, among the available option, low resistance means Kelvin double bridge method. Like that, while you're practicing also, whatever the answer is correct, that okay. But for other options also, what can be the suitable one? In that way, if you are going, all questions will be done. Right? Next one. Which bridge is used to determine frequency? Just now we have taken. Yes, Wien bridge is frequency. No, in the other paper he has given that. Which bridge is used to determine the frequency? Yes. What is that? Wien's bridge. Here also let us take Anderson's bridge. Of course, self-inductance. Anderson's bridge, self-inductance. So I am writing self. And De Sauty's bridge, capacitance. If you observe this question and earlier question, options are almost looking like same. Okay, De Sauty's capacitance. Wien's bridge is anyway frequency. Campbell's bridge, we can say, what is that? Campbell's modified form of Heaviside's bridge. On that context, we can say mutual inductance. What is it? Campbell's modification of Heaviside's mutual inductance bridge. So obviously, on that context, mutual inductance we can say. Right? Next one. Accuracy is defined as, sir, what is accuracy? An instrument is said to be accurate when measured values are close to the true value. Measured values are approaching the true value. Very simple. Check it. The measure of consistency of the meter reading. No. The smallest measurable input change. No. The ratio of the input to the output. No. So what is the answer here? Closeness. Between which and which parameter? Measured value and true value. Closeness with which an instrument reading approaches the true value of the quantity. Nothing but measured value is close to the true value, then that is called as accuracy. So simply, in the simple form I am writing measured value close to true value. Measured value is close to true value. That phenomenon is called as accuracy. Very simple. Right? That's what closely approaching or closeness, like that we can write. Next one. 2 voltmeters with ranges of 0 to 100 volt has sensitivities of 10 kilo ohm per volt and 20 kilo ohm per volt. What is the maximum voltage? Very important. What is the maximum voltage that can be measured when these voltmeters are connected in series? Nothing but 2 voltmeters are there. Different values are given. Those two are connected in series with the corresponding combination. What is the maximum voltage measurable? Now let us take this. Sir, here it is a numerical model. Sir, 2 meters are there. 2 meters are connected in series. 2 meters are connected in series. Okay. What is that first meter? full scale value 100 volt, second meter also 100 volt only. Therefore, 100 volt is the full scale value, 100 volt is the full scale value. And this is V1 and this is V2. Okay. What is the sensitivities of meters? 10 kilo ohm per volt, 20 kilo ohm per volt. So therefore, sensitivity of first meter 10 kilo ohm per volt. 10 kilo ohm per volt. And second meter sensitivity is 20 kilo ohm per volt. What he is asking? Maximum voltage. So therefore, with this combination, what is the maximum voltage? Now, very, very important. In this one, key point is there. If you hold that point, answer will be very easy. Sir, in order to get the V maximum, simply I am writing, sir, V maximum is equal to, what we can write? I maximum into R total we can write. What is that? Voltage maximum equal to current maximum as well as correspondingly R total. Is it not? Now let us take, sir, what can be the maximum current allowed by this combination? For that purpose, what am I doing now? Here, first I am finding its full scale deflection current. It's a full scale deflection current. IFSD is equal to 1 by S1. IFSD equal to 1 by S1. What is 1 by S1? 1 by 10. So therefore, 0.1 milliampere. So what is the full scale value of the meter 1? 0.1 milliampere. Same way, IFSD 2 I'm finding. So what is IFSD 2? 1 by sensitivity 2. So 1 by 20 means 0.05 milliampere. After this, generally confusion, there is a chance of getting confused. Kindly focus. Meter 1 full scale value is 0.1 milli. Meter 2 full scale value is 0.05 milli. But as both are connected in series, what is the maximum current allowed by the combination? Means majority of the people generally say that, sir, 0.1 is more, no sir, 0.1 is maximum, sir. I am not asking between these two which is maximum, no. Our requirement is what? By the combination, which current is the maximum current allowed? Which is the maximum current allowed? That is what our requirement. So that's why focus more. Sir, simple analysis I am giving. Through this, I am sending 0.01 milli. Both meters are safe or anyone get damaged. Means it can allow up to 0.1 milli. It can allow up to 0.05 milli, but we are sending only 0.01. Yes, both meters are safe. Suppose if I send this one, 0.05 milli if I send, yes, it can up to 0.05, it can be up to 0.1 milli. Yes, both meters are safe. Suppose if you are sending 0.06 milliampere, if you are sending 0.06 milliampere, this will be safe, but this will be disturbed or damaged, we can say. That's why with this entire analysis, which value can be the maximum allowed current? Maximum allowed current will be the 0.05 milli. So that's why with this combination, I maximum is equal to 0.05 milli. Very, very, very important. This itself is playing the major role in this. So let us substitute here. 0.05 milli means 10 power minus 3, right, into. Sir, what is the resistance? Now let us find out the resistance. Here, two ways are there. I am giving two ways here. What is that? Sir, resistance is equal to, or resistance of meter is equal to 10 kilo ohm per volt. What does it mean? 1 volt will be having 10 kilo ohm. But what is our voltage? 100 volt. So therefore, what we can write now? 10 kilo ohm per volt into 100 volt. You are going to get 100 into 10, 1000 kilo. So simply 1 mega ohm. Here also same procedure. R2 equal to 1 volt will have 20k, 100 volt will have dash. So simply what we can write now? 20 kilo ohm per volt into 100 volts. So therefore, answer will be 2 mega ohm. Answer is 2 mega ohm. So this is one method, but one more method is also there to calculate the resistance. So what is it? According to the given data in different questions, follow any one which is suitable. But I'm giving both here, both are possible. Sir, full scale voltage is there, full scale current is there. So simply R1 is equal to 100 volt by 0.1 milliampere. 0.1 milli, 100 volt by 0.1 milli, 1000 kilo. So simply 1 mega ohm. Either you take V by I formula or you take sensitivity into voltage, both will give same answer. Here also R2 is equal to, what is the value? 100 volt by current is 0.05 milliampere. You are going to get 2 mega ohm. Now tell me, meter 1 resistance is 1 mega, meter 2 resistance is 2 mega, both are in series. So what is the value? R total is 3 mega ohm. 3 mega. If you are simplifying this, we are going to get 150 volts. We are going to get 150 volts. This is the answer. So be clear, this current, getting this current is very, very important. Here we are not in requirement of which is maximum. No, through this combination, how much maximum current is allowed. So therefore, 0.05 milli. So answer will be 150 volt. Right? So option A is yes. Option B, 150 volt. Okay. Suppose by mistake, if you take 0.1 milli by mistake, we are taking, for example, what is that? V maximum is equal to, suppose if you take 0.1 into 10 power minus 3 into 3 mega ohm, 3 into 10 power 6. If you simplify this, 300 volt you will get. Why? Means if you are doing small mistake, like among these two, this is more, by the thought, if you are taking this 0.1 milli, 0.1 into 10 power minus 3, 3 into 10 power 6. So answer is 300 volt. But unfortunately, here 300 is not, if it is not there, it's okay. But sometimes 300 may be given. And here none of the above is also there. What is it? What we think? Okay, 300 we got it. None of the above, we take it here. No, 300 is the wrong answer. But how can verify that, sir? In the examination hall, how can verify? I mean, simple logic. What is its full scale value? 100. 2 meters full scale value itself is 100, means maximum voltage measurable 100, maximum voltage measurable 100 under normal condition. Under normal condition, what can be the maximum possible? Normally 200, but here more than 200 not at all possible. That is the reason why this is completely wrong. Whatever the mistake we do generally, I am doing that, I am showing that also. Yes, that is wrong. That's why, yes, 150, below 200, 100 and 100 is below 200 is possible. 150 is the answer. That's why be clear with the question and options also be clear. Right? Next question. Here, it is also very small thing. Right? The question is an ammeter with a range of 0 to 2 milliampere. So therefore, IM is given as 2 milliampere. Okay. Internal resistance of 10 ohm. So Rem is equal to 10 ohm. What is the value of shunt resistance required? So what they are asking? RSS they are asking. Okay. In order to increase the range to 100 amperes, so therefore I is equal to how much value? 100 amperes. Now RSH is equal to Rm by, what is the formula? I by Im minus 1. Yes, in the topic also I told you, extension of range topic also very popular in various competitive examinations. Yes, this is the model. Now, what is Rm? 10. What is I? 100 by. What is Im? 2 milli, means 2 into 10 power minus 3 minus 1. Right? Now, here this value will be 10 by 100 by 2, 50, 50,000. So simply 50,000 minus 1. Guys, don't get confused with this one. 50,000 means 49,919, again dividing. Don't get confused. 50,000 minus 1, approximately 50 we can say. 10 by 50,000. 10 by 50,000 is the answer. Choose the value properly. 10 by 50,000, you may be getting corresponding 200 microampere. In that way, get the value properly and check it. See the options: 200 micro, 200 milli, 2 micro, 2000 milli. Yes, you can simplify and select one answer. I'm leaving it for you. Kindly try this. Right? Next. The pressure coil of a dynamometer type wattmeter. Guys, pressure coil means which coil? Potential coil. Pressure coil means potential coil. Right? Potential coil must be always highly resistive. Potential coil must be always highly resistive. So direct answer is highly resistive. Right? Next one. Minimum number of wattmeters required to measure 3-phase. See the question carefully. 3-phase, okay. 3-wire, balanced or unbalanced? 3-wire, balanced and unbalanced means all sort of loads they are asking. 1 is not possible universally. 3 is also not possible. That is the reason why. What is the answer? 2 wattmeter. Straight away question we are taking in the class also. The corresponding minimum number of wattmeters required to measure 3-phase, 3-wire is there, balanced is there, unbalanced. So universal method is yes, 2 wattmeter method. Right? Next question. A meter has a strain gauge factor of 2. Gauge factor of 2. Its nominal resistance is 120. Undergoes a strain of 10 power 5. The value of change in resistance responds to the strain. Change in resistance responds to strain. First of all, let us write the data. Gauge factor is equal to 2. Gauge factor is equal to 2. And nominal resistance means R value is 120 ohm. And strain means epsilon, that is delta L by L. Delta L by L is equal to 10 power minus 5. What they are asking? Change in resistance. So therefore, simply delta R they are asking. What is delta R? Now, sir, what is the gauge factor formula? Gauge factor formula is delta R by R by delta L by L. Delta R by R by delta L by L. Therefore, simply delta R by R is equal to gauge factor into delta L by L. But what we require? Delta R we require. Therefore, delta R is equal to gauge factor into delta L by L into resistance. Over. Now, so what is gauge factor? 2. What is a strain? 10 power minus 5. 10 power minus 5 into what is resistance? Resistance is, nominal resistance is 120 ohm. 120. Now, what is the value? 120 into 2. 240 into 10 power minus 5 ohm. 240 into 10 power minus 5 ohm. So, which is a suitable value? Which is suitable value? 240 into 10 power minus 5. If I am bringing this side, so what will be there? Simply, right? Among the corresponding values, choose the correct option properly. Simply 4.8, 3.6, 1.2. So this only. So kindly 20. What is that? 240. Yes, near to that value. Check it here. Right? Next. A DC voltmeter has a sensitivity of 1000 ohm per volt. So what is given? Sensitivity is given. Sensitivity is equal to 1000 ohm per volt. When it measures half full scale in 100 volt range, very important. Full scale value is 100 volt, but they want to measure half full scale value means 50 volt. Right? When it measures half full scale in 100 volt range, so what is the range value? Full scale value 100. They are interested to measure the corresponding half of the full scale. So therefore, what we can say? Yes, this value is correspondingly 50. In order to measure this 50 volt, what is the current? In order to measure this 50 volt, what he is asking? What is the current required? So therefore, they are asking like current value. Current is how much? Now tell me, in order to get the current related to 50 volt, now what we require? current related to 100 volt is known, we can make it half. So therefore, what is the value here? How to get it? Very simple. Full scale value of voltage means what can be the current required? Of course, full scale deflection current. What is IFSD formula? 1 by S. So therefore, substitute over here. What is that? 1 by 1000. 1 by 1000 nothing but 1 milliampere. Now tell me, for 100 volts measurement, that is a full scale measurement, full scale current required is 1 milliampere. For 50 volt measurement, what is the current? For 50 volt measurement, what is the current? Very, very simple. I is equal to simple 50 by 100 into 1 milliampere. So what is the value? Simply 0.5 milliampere. Direct question, but only they have given sensitivity is given. We have to get the value of current. That's it. Simply for 100 volt, 1 milli, 50 volt, how much? Of course, half of that, 0.5 milliampere. So what is the answer? Yes, 0.5 milliampere. Right, next one. A 230 volt, it is also numerical one. A 230 volt, 10 ampere, single phase energy meter makes 90 revolutions in 3 minutes at half load. 90 revolutions in 3 minutes at half load, rated voltage and unity power factor. All values are given. And if the meter constant is 1800 revolutions per kWh, meter constant is 1800 revolutions per kWh, then it's error at half load. He is asking error at half load. Be clear with this, sir. Error at half load we require. What do you mean by error at half load? Energy measured at half load minus energy true at half load by energy true at half load into 100. Why, sir? If you want to calculate the error at half load, you want to have measured at half load, true at half load compulsory. So how do you find out? Very simple. Sir, energy true at half load. Energy true at half load. So what is the value? Very simple. What is the energy formula? 230 voltage into current. But which current? Half load. 10 is given. 10 is given as a full load, definitely. Loaded value. But we require half load. So therefore, 230 into 5. That is what? Half load into power factor 1. Okay, power factor is 1. V into I into cos phi divided by 1000 I'm converting that into kilowatt. Right? Kilowatt into, what is the time? Time of operation is 3 minutes. So therefore, 3 minutes I'm converting them into 3 by 60 hours. So therefore, this value is kilowatt hour. Okay, what you have done? V into I into cos phi by 1000 means kilowatt, 3 minutes, 3 by 60 hours. So therefore, kilowatt hours. Now, if you are simplifying this, you will be getting 0.0575 kilowatt hour. 0.0575 kilowatt hour. This is the true value of energy. Okay. So after getting this true value of energy, what else we require? Measured value. Now, energy measured at half load. So what is this energy measured at half load? The point here is, sir, here how many revolutions? 90 revolutions. This is the corresponding meter constant. Now check it. If the meter is making 1800 revolutions, it should give 1 kilowatt hour. But in our experiment, how many are made? 90. So therefore, what we can write now? 1800 revolutions should give 1 kilowatt hour. But how many revolutions are there? 90 revolutions. So how much energy? But people doubt is, sir, we have taken half load here. But why we are not taking half of this value means, see the question carefully. 90 revolutions are made at which load? half load only. So therefore, whatever the 90 we are taking, that will be related to half load only. That's why don't make it half further. So therefore, if we simplify this, we are going to get 0.05 kilowatt hour. 0.05 kilowatt hour. Now, energy true is there, energy measured is there. Now the question is percentage error at half load. What is energy measured value? 0.05. What energy true value? 0.0575 divided by 0.0575 into correspondingly 100. Okay, now if you simplify this, you are getting 13.04%. But small minus large, so minus 13.04% is the error at corresponding to the half loading condition. Now see the options. Do you have any minus value? No, but 13.04 both are there. One is with slow, one is with fast. What does it mean? Check it here. Sir, measured value is less than the true value. Measured value is less than the true value. That's why you have got negative sign. So now measured value is less than the true value. What does it mean? If the measured value is less than true value, that means the disk is rotating with less speed. Then only the reading will be less. So therefore, what we can write here? Sir, 13.04%. Instead of writing minus, we can write slow. Either this may be there in the options or this may be there. But in this question, this is given. So both are correct only. But don't keep like this. Minus 13.04%, comma, slow. Don't keep minus and slow both. Either you keep slow or you keep minus sign. That is okay. So this is the answer. So answer will be, answer is what? Yes, 13.04% slow. Right? Next question. The current flowing through the resistor R. The current flowing through the resistor R 100 plus or minus 0.3% ohm. I is equal to 2 plus or minus 4% ampere. 2 plus or minus 4% ampere. The limiting error in the power dissipation in the resistor. The limiting in the power dissipation. What is the power dissipation formula? P is equal to, what is the formula? I square R. P is equal to I square R notation. So therefore, P is equal to I square R. Okay. Now, so what is I? I value is 2 plus or minus 4%. 2 plus or minus 4%. This is current. What is resistance? 100 plus or minus 0.3%. 100 plus or minus 0.3%. But here it is I square. Don't forget this. I square into R. Sir, if any parameter square is there, true value square, as it is you take it, right? Plus or minus. If any error value square is there, we know that, yes, that power with respect to this error must be multiplied. Okay, this is the value. What we have done? True value square is there as it is squared. But error value square is there, we should not take the square, we should multiply with the power with the corresponding error into 100 plus or minus 0.3%. 0.3%. Okay, now, so what will be there? Sir, 2 square 4 plus or minus 8% and 100 plus or minus, what is that? 0.3%. We know that simply multiplication is there, no? Multiplication is there. 4 into 100, 400 plus or minus. Multiplication is there, of course, error should be always added. So therefore, answer is 8.3%. This is the power total value. But what he is asking? The limiting error in the power dissipation. Only error they are asking. So simply, what is the error formula? The error formula is 8.3%. Error formula is 8.3. Yes, answer is this. Error formula is 8.3%. Right? So the next question is a 0 to 150 volt voltmeter. A 0 to 150 volt voltmeter has an error of plus or minus 2% of full scale deflection. Right? What is the range of readings if true voltage is 50? So what is the given data? Full scale value is given, that is 150 volts. Full scale value is given, that is 150 volts. 2% full scale means guaranteed accuracy error equal to plus or minus 2% is given. How, sir? If any error with respect to full scale value, that is what guaranteed accuracy error. And what is the range of readings if a true value is how much value? 50 volt. Okay. What is asking? Range of the corresponding reading. In order to get the range, what we require? Percentage limiting error. Therefore, percentage limiting error is equal to full scale value 150 volt by true value 50 volt into what is the guaranteed accuracy error? Plus or minus 2%. Okay. Now, if you are simplifying this, 150 by 50, 3. So therefore, 3 into 2 means plus or minus 6%. But he is not asking the percentage limiting error. He is asking the range. So that's why what we can write with this. So therefore, V is equal to true value is 50 plus or minus 6% is its true value error, that is percentage limiting error. Now, sir, what is it? 50 plus or minus 6% of 50. 6% of 50 is how much? 3. Now, what we can write? 50 minus 3, 47. 50 minus 3, 47 to 50 plus 3, 53. So therefore, 47 volt to 53 volt. What is the range? 47 volt to 53. Yes, option B. Right? So these are the previous questions from the measurement subject. Thank you. All the best.